This video is part of my series with Chris showing you how to decrypt protocols such as HTTPS, as well as QUIC. In a previous video, which I've linked here and below, Chris showed you how to export keys on a Mac, how to use those keys in Wireshark so that you could decrypt encrypted packets. In this video, we're continuing the discussion looking at protocols such as HTTPS, how that's different to HTTP version 2, how that's different to QUIC, which is an emerging protocol which you're most likely using right now if you're watching this video on YouTube. Now, if you want to see part 1 of the interview, please use the link below. Otherwise, continue watching, where Chris and I talk about the various protocols in use today. So if you're on the bottom left where it says Hypertext Transfer Protocol 2, can you just expand that, bottom left?
Absolutely. You bet. Actually, David, that's a great question and a good place for your eyes to go, because when I first started to decrypt TLS sessions, I saw HTTP 2 and I went, oh, there's more going on beyond that lock than I thought. So it's not just HTTP 1.0 or 1.1. Now HTTP 2, or even with the next generation of HTTP, now we see HTTP 3 as well.
So can you, what is, just for everyone's benefit, can you explain what's HTTP 2, and you mentioned HTTP 3, and I saw your file name is called QUIC. What's all that about?
Ooh, good question. Okay, so here it is, plain and simple. With HTTP 2, or actually let me back up, HTTP 1.
Yep.
HTTP 1.0 allowed me to establish a connection with you. Imagine, David, you be the server, okay?
Yeah.
I establish a connection to you over TCP, handshake, /ACK.
Yeah.
And I immediately then ask you for a file, get david.png.
Yeah, send you a picture.
You send me that file.
Yeah.
You send me the file and I say, great, thank you, done. Okay. And I shut down the TCP connection. Well, that's not very efficient.
No.
HTTP 1.1 allowed it for pipelining. So then I say, hey, David, go ahead and send me the PNG file. Go ahead and send me your david.png. You go and send that over. Immediately after that, I could say, now send me Bumble PNG.
Yeah.
And then you send that one. And then I say, okay, send me Chris. Then, send me GREER. Send me Wireshark. I could do all of these requests one after the other over a single TCP stream. Efficient.
So the session was kept up, yeah?
Correct. The TCP session was still up.
Yeah.
Problem. We started to run into some issues where TCP became a bottleneck.
Yeah.
Where we now need 100 different images, files, things to bring over web, but I'm doing it over an individual TCP channel. Or even if I started up several TCP connections, I could still only use one request over one TCP connection.
Okay.
What HTTP 2 does is it allows me to set up streams on top of one TCP connection. That's what this is up here. You see, it says settings, and basically I'm going to collapse all this, David. This is a better packet to show you this with. You see all these streams?
Yeah.
Basically, you could think of each one of these streams as an individual TCP connection of its own.
Within the main, within the main session, yeah?
Yeah, it just allows me to multiplex requests over a single TCP stream. What that allows me to do is now, instead of saying, hey, David, give me that David image, and you send it, then Bumble image, now Chris image. Now I can say, hey, David, give me David, Bumble, Chris, GREER, Wireshark, TCP. Give me everything you have. Yeah. And you can then start to work on those requests all over one TCP connection. That's what HTTP 2 is. Just to keep it simple. So when I say get here, and I come down here, now this is, you see in Wireshark shows me, it helps me out. It says, here's a stream. So this is stream 15. It just gives me a stream number, and there's a bit more detail in there, but we'll leave that simple. So the stream ID is 15, and that's where we're doing a get. All right. So that get, what I'm going to look for, what my eyes are going to do is I'm going to look for when's the next time I see 15. Or I can even come here and I can say follow HTTP 2 stream if I want to. Let's actually do that. I got some stuff that came up. I'm going to close this out. I just want to come back to my packets. Basically, so here's the get for stream 15, and the response came here. This was the next packet that had stream 15 in it. And this is my 302 found. So the server says, okay, great. We got some stuff. Let's go ahead and see what the server came up with. If I expand this, 302 found. Now here's the key. This is what basically this is telling us, David. If we come down, it's quite a bit of HTTP information going on here that we're going to jump over. I know this is a lot going on here, but basically, so my response code is found. So the status code is 302, which means, okay, I found you, but I'm actually going to redirect you somewhere else. Your location that we're talking to is youtube.com, but this is the key here. The server's coming back and actually suggesting an alternate service. If I expand this out down at the bottom, what the server's saying is, hey, this is great that we're talking over TCP using a TLS encrypted handshake HTTP2. However, what do you think if we jump over to QUIC and we use HTTP3? And this is actually QUIC draft 29 that it's suggesting. But the point is the server's saying, hey, I can talk to you. That's wonderful. Not an issue at all here. But do you mind doing it over QUIC?
I'm hoping you can explain what QUIC is for everyone who doesn't know.
Absolutely. So QUIC is, it came from Google, but what QUIC is, it's basically the newest transport layer protocol. For the longest, we were only running two protocols. As you know, Dave, we were just running two protocols at the transport layer. TCP, connection-oriented.
Yeah.
UDP, connectionless. That's it.
Yeah.
Unless you can think of another transport protocol that, I'm missing out on. But those are the top ones.
Yeah, the top ones, yeah.
What started to happen to move most of our data, those are the kings.
Yeah.
So what started to happen was basically Google was thinking, we got to speed up the internet. And a bottleneck that we have is TCP. I mean, look, we have to do a TCP handshake. We have to do a TLS handshake. So they were thinking, if I can go back to my packets here, and if I come up to the top, from the time that I send that SYN, let me just set that filter one more time. From the time that the user sends the SYN until the user gets its first usable byte of data, right? Basically, this 302 found, from the time it begins to the time of 302 found is too long. There's too much chatter, too much going on. We got to simplify this and make it to where David could send, basically establish a connection in one round trip and even be able to get data on that first response. One round trip.
Okay.
That's the goal of QUIC. So what QUIC is, after the server says, hey, do you want to go to QUIC? Basically what happens down a little further in this PCAP, actually just a few packets later, the client opens up a QUIC connection to the same IP address. Only, check this out. Here's IP. Now we're over UDP. We're going to UDP 443.
Yeah.
Right? TCP 443 is the one we've been working with for a while. QUIC is over UDP 443, but now what we're doing is we're establishing a secure conversation over UDP, and that picks up basically what my browser did is it moved over to QUIC, and that's the application that it's using to be able to send data at layer 3, or at layer 4 is QUIC, and then HTTP can sit on top of it. In fact, David, right now, the viewers are probably watching this video over QUIC. Anything you search on Google is going to be over QUIC. You check your Google Mail, you go to YouTube, even Facebook is now flipped over to QUIC. So think of it as TCP2 without some of the bottlenecks that TCP creates.
It's amazing. I mean, I'm trying to remember when did the draft come out? It's only about a year ago that they started moving towards this. I can't remember when did it actually get ratified or whatever it is.
May 2021. So
so
5 months ago.
5 months ago, yeah, it's not long.
But they've been working on it since basically Google first incepted this. It started out as GQuick. It started out as Google Quick Internet Connections, and that was back in 2012. So this standard is 9 years in the making.
So like if you use Chrome, most people use Chrome or Firefox. If you go to any of the big websites, like you mentioned, Facebook, Google, and some others, it's going to be QUIC. So at some point, I'll probably have to get you back for a whole deep discussion on this, because we're going to see more and more of this. Or can you give us like a quick tour of QUIC versus a TCP and HTTP?
Absolutely. No problem. In fact, what I would suggest to the listeners, or anyone that's watching this right now, fire up Wireshark.
Yeah.
Look at this video through the lens of Wireshark. And what is your transport layer protocol? It's probably UDP.
Yeah.
So if you only see UDP there, and there's just data sitting within UDP, that's likely QUIC sitting on top of UDP. We just missed the initial handshake setup, so Wireshark doesn't know how to decrypt it. It doesn't realize that it's QUIC. We're only going to see it. We're only going to see it identified as QUIC if we get some of this initial handshake behavior before we actually see the application. Very briefly, QUIC is simply sitting on top of UDP. It establishes a connection, but notice this. In the very initial packet, think of this as almost like the TCP SYN.
Yeah.
Right? This is just, hey, how you doing? Do you talk QUIC? Are you open on this UDP port? We send out that initial, and if we come down to our QUIC information, notice this. The TLS, client hello, is embedded within the QUIC initial. Now, there's a lot we could say about the QUIC initial packet. Let's keep it very simple. Basically, David, what I'm doing is I'm saying, hey, here's my IP address. Here's yours. Here's my port. Here's yours. This is the most important part. The destination connection ID. I'm establishing now at the QUIC layer this connection identification number. Here's you. Here's me. Think of these as almost like, let's just call them, just to understand the idea, it's almost like a new port number in a way. Like, I'm going to come talk to you on this port. Here's who I'm coming from, just so we have an understanding here. Here's what's cool about QUIC. Now the underlying stuff can change. The IP addresses can change. Let's just say that I'm watching this video from my office and I walk out to my car and I flip from Wi-Fi over to the LTE network.
Yeah.
The whole network changed. Even the UDP port numbers could change. Right now, TCP would need to reconnect to that new network.
Yeah.
QUIC, I just keep coming back to you and I have the same connection ID, and we can just resume this connection even if I change networks.
That's cool.
Pretty sweet.
Yeah, that's very good.
And from the very initial packet, I'm sending my client hello, that TLS 1.3 hello, which is one of the reasons why it took so long to get here with QUIC, is that they were waiting until we had a one round trip way of establishing the connections. That happened with TLS 1.3. So TLS 1.3, client hello is going out the very first packet. Do you notice what we have here? We don't have that TCP handshake. We already bought ourselves one round trip.
Yeah.
Immediately, right out the gate. Now with this, once this initial ends, and really I'm only looking at one handshake before I'm starting to move data. So from the time I start the conversation with that server until the time I'm actually using the application and getting data is several round trips less.
Yeah.
Or at a minimum one, if not more, especially when I'm going back to a conversation I've had in the past. So that's your high level QUIC. It's simply a new transport layer protocol that is poised to take on a lot of the workload on the internet. That's already happening with YouTube. It's already happening with Google. It's already happening with Facebook. And we're pretty sure that as things move forward, many more will follow.
So, I mean, the big difference here is, just to summarize, is TCP is slow, lots of overhead with TCP. So rather than using TCP, we're using UDP. It less round trip stuff. We don't have to keep checking things. I mean, TCP, you and I have been in this game for a long time, was developed in a world that was very different to today's world. Slow connections, lots of drops, stuff like that. So we're replacing TCP with UDP, and then we're running QUIC directly over UDP to get rid of like the slowness in TCP and TLS. Is that right?
That's correct. Basically, TCP, we start to have something called head of line blocking.
Yeah.
And what that is it's a concept where basically I can go back to the scenario where I was sending you a lot of requests at once.
Yeah.
I would say, hey, David, give me this image, that JavaScript, give me all this stuff. Give me. And if there's any problem on the network, if there was any packet loss or any type of out of orders or anything that would mess up the TCP connection, the application would come to a screeching halt. Basically, everyone pull your brakes. Hang on, there's been a lost packet. So even if you had let's say you got the request for David, Bomble, and Chris for all 3 files, but there was some packet loss in you responding to just one of those responses. Well, TCP doesn't know about the data that's above it. So TCP would go, wait a second, everyone, stop, hang on, retransmit. Okay, now we're good. Now we can continue and move this application along. That's called head of line blocking. If someone ahead of you, we've all been there in the supermarket, we happen to pick the one lane where someone had a credit card problem, they had to call their bank, and there you are. It just bogs the whole thing up.
Yeah.
In a similar way, that's what head of line blocking does, especially over TCP. It cares too much about every byte.
Yeah.
So what QUIC does, QUIC cares too, but what it does is it handles that recovery on a stream level. So now I can tell which stream had the loss. Was it David? Was it Bomble? Was it Chris? Was it GREER? Which one of those files that were requested actually experienced the loss? Let's only impact that stream, and the rest can keep going as if nothing happened.
That's great.
That's one of the benefits to QUIC.
And sorry, go on.
And the point, the whole reason for doing it over UDP is because now I can plug this transport layer entity, this new thing, I can put it within a packet, and I can send it to any kernel in the world. All kernels support TCP and UDP.
Yeah.
So now imagine if I took QUIC and I put it right over IP.
Yeah, nightmare.
I'd have to imagine what would happen from a network perspective. Okay, the routers are saying, what is this? Access lists would break. Firewalls would need to understand what it is. Load balancers couldn't handle it. But putting it over UDP, now all of this infrastructure just treats it as a UDP stream.
And it's interesting because it's using UDP port 443 as the server, is that right?
Yes, it is. That's the standard QUIC port number is UDP 443.
So just the sort of the mechanics, initially, if I open up Chrome and I go to YouTube, the initial session is TCP HTTPS port 443, yeah? And then you had that like redirect, and then it tries to move to QUIC. Is that correct?
That is correct. So not all networks are going to support QUIC yet.
Yeah.
There's some environments, I have clients that are like, we don't want UDP 443 because we don't trust it yet. So they literally block it.
Yeah.
So that's fine. YouTube can handle that. YouTube's like, fine. Oh, you don't want to go QUIC? Let's keep on TCP. That's fine. That's not a problem. So it could be from a security perspective, or it could be from a browser perspective. What if I'm using a browser that doesn't yet fully, most of them do anymore, but let's just say I was using a browser that doesn't support QUIC yet. So the server could come back like it did here. The 302 found the alternate service, that one that we looked at earlier.
Yeah.
The alternate service isn't a must. It's just a suggestion, right? So if the client can do it, then the client will initiate QUIC. If not, it'll say, forget you, I don't know QUIC. Let's keep going down the TCP lane.
That's brilliant. So just to step back right to the beginning of what we discussed, the trick here, or the takeaway here, is that you've got to get those session keys. And I'll link it again below the video. You've given us a document where you show how to do that for different operating systems, yeah? So somehow you got to get those keys, and like you did on the Mac, export it so that Wireshark can grab those keys to do the decryption. Is that correct?
Absolutely. So I'll give you, there's an article that shows you how to do it, or if you'd prefer to see how to do it, that's where I would just link back to the one on my channel that shows you Windows. I do it on Windows 10 with Chrome, and I demonstrate how to set up that environment variable, how to store it, how to start up that capture, and get the packets that you can then bring that key into.
Yeah, that's great. I'll link to both the article and your video below. So anyone who wants to watch, how to do this on Windows, go to Chris's YouTube channel, have a look at that. Anything else you want to share, Chris, about this, or have we kind of covered the basics of it?
Yeah, absolutely. I think, boy, there's a lot to share about TCP. I think we're just we're scratching the surface, but I think what I'd like everyone to take away from this is that there's a lot going on at the packet level. Not everything needs to be decrypted in order to troubleshoot, especially using TCP. There's a lot we can do. We can look at retransmissions. We can look at network round trip times, application response time. For me, I also don't want you to think that if I don't have decryption, then Wireshark is useless.
Yeah.
That's not true either. A lot of the troubleshooting that I do is without the key, right? Someone will send me a PCAP and they'll say, hey, what's going on here? What's wrong? And what are the odds that they were capturing the TLS key at that time?
Yeah, exactly.
Pretty unlikely. So that means I'm going to have to get in and do some encrypted analysis. So Wireshark is still a very powerful tool with or without decryption. However, since so much is encrypted, now it does really help us to be able to do some decryption, to take a look at the gets, the response strings, what file was held up, what are some of these underlying things. And especially as we're moving into QUIC after the first packet is completely encrypted.
Yeah.
So in order to make heads and tails of what's really happening, having that decryption option is nice. But back to just repeat myself again, I just don't want everyone to think if I don't have decryption, then I have nothing. Why even look at the packets? Because that's not true. There's a lot we can still see even in an encrypted flow.
Yeah, I think that it's good that you highlight that, because a lot of people will have that concern that, if I don't capture the keys, I can't really see anything. So let me ask you the difficult questions now. In a subsequent video, or can you briefly explain how on earth would I capture the keys with man in the middle, or a server? Is that like a whole separate video that we should do?
Yeah, that's something we certainly could. We could look at doing that for sure. I think it's not as easy as it sounds.
No.
For good reason.
Yeah, exactly.
Right. There are also, I find with a lot of my clients, what they do is they just end up having a TLS proxy.
Yeah, I wanted to ask you
what
that
proxies. Means.
Yeah, go on.
Yeah, so basically it's known that it's a TLS entity. Literally, it's a box that everything points to. All browsers know that that's their web proxy. And it actually terminates the connection. Then that proxy box turns around and establishes the connection to whatever site they're going to. So they have a central focal point where TLS sessions are stored. But that's something that IT knows about. Everybody's got it in there. It's not malicious. Yeah. It's a designed, built-in place where keys are captured. That said, that technically is a man in the middle, but everyone knows about it, and it's a policy kind of thing. To do it just sitting in a coffee shop, that's a whole different story.
So, Chris, this is brilliant. You've shown us, and just make sure that I've got my summary correct. You've shown us how do you export a key so that we can capture the session and decrypt it with Wireshark. You've shown us how to select that through Wireshark. You've explained QUIC. You've explained a whole bunch of stuff. What are your most important pieces of advice for someone who wants to learn Wireshark? So, is it important? And I think you've answered that already. And then how would you learn it? If you were starting today, how would you suggest someone learn Wireshark? I mean, I would suggest going to look at your YouTube channel as an example, but are there any other resources that you found that have been really beneficial?
That's a great question. I was there myself. How do you learn Wireshark? And a big one is to install it and look at it daily if possible. Right? Protocols are languages.
Yeah.
Right? We could be speaking in English, Spanish, Portuguese, but the more we do it, the more we're going to understand what's really happening. Same thing with Wireshark. We can't just break it out once a year when that problem happens. It's not going to work. So install it, and then there's content like my YouTube channel. I invite everybody to stop by. I have a mini series on Wireshark. It takes you from the installation, the configuration, setting up a profile, setting up a filter, and some basics on how TCP works. I know you, David, you have a video series on Udemy. You have some Wireshark content out there as well. So there is some great stuff on YouTube. From a book perspective, you know what I suggest people do, and maybe we can link this down below as well. There's some really good books that just talk about the protocols themselves.
Yeah.
Right. So one that I really like is TCP Illustrated.
Yeah.
And it's not your casual reading book. It's great to put you to sleep at night if you really need that. But it digs deep into the protocol itself that we're looking at with Wireshark. So there is some great content out there. A few searches, and I'm sure you'll be able to find it. So he's got it.
I need to ask you the question: is second edition as good as the first edition? Because I see some people complain.
It's better. That's the one. You have it. Yeah, that's the book. It's a great book.
I'll link that below. I mean, it's interesting because there are books. I have books on Wireshark per se, but you pushing us more to learn the protocols rather than like just trying to learn Wireshark. Yeah.
Yeah, absolutely. In fact, in my courses, I spend the first, if the course is 2 days, I spend the first hour on the interface, and then boom, we're into the protocols. Let's actually learn to use it.
Yeah.
And then that will then teach us more about the interface and filters and buttons and the actual analyzer itself.
No, I agree with that strategy. I always like to use the analogy. It's like trying to learn to ride a bicycle. You're only going to learn by doing it and falling off a few times. Yeah. So, Chris, really want to thank you for, demonstrating Wireshark. I'm going to twist you to come back. In our next video, are you going to be able to show us like the dodgy protocols on a network and how to discover like dodgy stuff happening?
I think that would be a fun track to go down. Let's go ahead and take a look at a stream of data in Wireshark, and let's build some filters that will specifically point out the stuff that's weird.
Yeah.
And be able to identify that quickly. I think that's a very important skill, especially for cybersecurity professionals or if we want to go down the security path.
Yeah. So everyone, please put in the comments below, what kind of stuff would you like Chris to answer? What kind of videos would you like him and I to create? I definitely want to create a bunch of videos with Chris if he's up for it. What kind of stuff would you like us to, talk about? And make sure that you go to his channel, subscribe to his channel. He goes into much more detail than I do. So Chris, thanks so much for, this video. Looking forward to the next one.
Absolutely, David. Thank you so much for having me, and appreciate anybody that watched. And this has been great. I've had a good time.
Brilliant. Thanks.